Okay, in this lecture we're going to talk about simplifying radical expressions that involve fractions. So if you look at these examples here, the first one will involve a quotient. So let's look at the first example. And in these cases what we're doing is we're just simplifying each expression. Right, part A. Let's suppose we want to simplify the cube root of x to the fifth y over the cube root of x squared y to the 5. Right, now with this one here we have the cube root, so we can use our rule for quotients. This will be the cube root of x to the 5 y over x squared y to the 5. Okay, so now we can do the part inside the square root, or the cube root, and of course we subtract here, so it'll be x by 5, subtract 2, and y to the 1, because this is a 1 right here, subtract 5. So this will be the cube root of x to the 3, y to the negative 4, which of course we must write as positive exponents, so this will be the cube root of x cubed on y to the 4. Now we haven't finished yet, because we can write this as the cube root of x cubed over the cube root of y to the 4. So we can write this as, of course, the cube root of x cubed is x, and we can write this as the cube root of y cubed by y to the 1, which of course is equal to x over y by the cube root of y. Okay. Alrighty, so that's how we do that. Now, of course, we want to make sure that we don't have any radicals in the bottom part. So when we come to this stage here, we have to ask ourselves, well, we've got a radical here, so what are we going to be able to do with that? So how do we change that radical? So we have x over y, and of course we'd have to multiply by the cube root of y by the cube root of y by the cube root of y. Alright, and of course we'd have to do that up here as well. Cube root of y by the cube root of y. Okay, and of course what we have here then is this will be y, so we'll have a y squared on the bottom now, and we'll have an x here, and now we've got two of these, so this is actually the cube root of y squared. And so now we have the radical in the numerator, which makes it the most simple form. Okay, part B, let's suppose that we have the fourth root of 6 over a to the 8 minus the fourth root of 3 over a to the 16. Alright, now what we have here, alright, of course, is we need to see if we can simplify this. So to do that, we apply our radical rule for quotients here. So this would be the fourth root of 6 over the fourth root of 8 minus the fourth root of 3 over the fourth root of, that's a, sorry, a to the 8, alright, and this will be the fourth root of a to the 16. Right, so this becomes the fourth root of 6 over, let's have a look here, the fourth root of a to the, let's have a look here, so 8 will be squared, a squared to the 4, okay, subtract the fourth root of 3 over, let's have a look here, it's going to be the fourth root of a to the 8, a to the 4 to the power of 4. See, I'm looking for a power of 4 that will allow the fourth root to cancel out. So this will be the fourth root of 6 minus the fourth root of 3. Now over these, this one here is going to be, of course, a squared, because the fourth root of a squared to the 4 is a squared, and this one will be, of course, a to the 4. Right, now we'll need a common denominator, so we'd have to multiply this one by a squared, so I'd have an a squared fourth root of 6 minus the fourth root of 3 over a to the 4. So I end up with a squared by the fourth root of 6, okay, minus the fourth root of 3 all over a to the 4. Okay, and that would be as simple as we can possibly get it. We don't have any radicals in the denominator, and we have combined together the numerator.